So, can you see my screen? Can everybody see my screen? Okay, you can use chat window to communicate to me if you have any queries, any problems. Okay, good. So let's start with today's session. I'm already recording the session. Yeah. So in the last class, let me give you a quick recap like what we discussed in the last demo class, and then I'll move on to the architecture part. So in the last class, we discussed about the very introduction part of HANA. I didn't discuss any technical details about SAP HANA. I was discussing about what is HANA and why HANA is required for the business and what are the different capabilities of HANA like in-memory computation, hardware innovations and software innovation. Then we have seen different editions that are available to purchase HANA, different hardware vendors that we have, and then finally we have seen what are the different kinds of projects lively that you can work on in the real time. There are 4 different kinds of projects that you can work on that already we have discussed. Now, today we are going to discuss the very basic part of SAP HANA, that is the architectural part. The real-time empowerment, this architecture part may not be helping you to work, but when you are learning any technology, it is good to know the architectural part of that technology. So that is the main reason that we are covering this architecture part. And if you are planning for the certification, from this architecture part, you can expect around 5 questions. So if you are going for the certification, so architecture part is important for the certification. Even if you go interviews, in the interview point of view also, architecture part is little important. Yeah. So let's start off with this. So this is a high level architectural part of SAP HANA in which you can observe at very low level. You can see different kind of source systems that data has actually resides in those systems. The data resides in any kind of system. It could be business suite system, it could be ECC, or it could be CRM system, or SEM system, or it could be BW system, or any third party non-SAP system also, right? So the data resides in these systems. What is our main motto here is to replicate the data from these systems, to HANA system. So to replicate the data from these systems to HANA system. So what is my HANA system here? There is a separate HANA system, HANA database installed. So I need to transfer my data. From the source system, to the target system. What is my source? Source could be anything. What is my target? The target here is HANA. So I'm just replicating this data into the HANA database, but directly the replication may not be possible. You need some tools to replicate the data from these sources to the target system. Those layers are nothing but this one. So I'll come to that point. In the demo we discussed in memory. I'll discuss this point. So here what I'm saying is these are the ETL layer. So these ETL layers are moved. These ETL layers nothing but ETL tools like SLT. We will discuss on more in details the data provisioning part. So this is called SLT. This is called DS or data services. Using these two tools, we replicate the data from the source systems into the target system. What is my target system here? What is my target database here? HANA. So where the data resides, actual data in the source system. So what kind of source system? Source system could be anything. So like let's say as we discussed in the demo class, we were discussing about the Walmart system. So everyday transactions actually stores in the transactional system. We call it as OLTP system. So it could be any other non-SAP system as well. So to analyze the data, to process the data, to make a report out of that data, you need to transfer the data from the source system, that is transactional system, to the HANA database. You need to transfer that into the HANA database. So to transfer the data from those source systems to the HANA database, you need ETL tools. What do you mean by ETL here is extraction, transformation and loading. So what do you mean by ETL is extraction of data, transformation of data and loading of data. So what are the different tools that I can use here is, one is SLT, another one is a DS. We would be using these two tools to load the data from the source system to the HANA system. Practically we will see that. So this is the high level architecture picture where the data resides, where we are moving the data, using what tools we are moving the data. Okay, so in the last class we discussed HANA is an in-memory database. HANA is an in-memory database. What do you mean by in-memory? The in-memory is nothing but you are keeping the data in the main memory. You are processing the data in the main memory. What do you mean by main memory here? Nothing but RAM. That is random access memory. So the primary memory here is the RAM, not the hard disk. So you are processing the data and you are keeping the data in the RAM. Entire processing of the data directly happens in the RAM itself. Okay, that is the processing of data inside your RAM is called, inside the HANA database, that is nothing but RAM, is called in-memory computing engine. In-memory computing. The engine that processes the data in the main memory is called in-memory computing engines. There are different kinds of engines are available in HANA server or HANA database. There are different kinds of servers are there. These servers are actually designed to process the data in the in memory. These servers are designed to process the data in the in memory. What are the different kinds of engines? What are the computing engines? So those engines are like calculation engine, planning engine, OLAP engine, join engine, even graph engine. So many different types of engines are there inbuilt within HANA. Inbuilt within HANA. What are those engines and what are the purpose of those engines? We will see one by one. So for the time being, this is the high level architecture in which you can see the in-memory computation engine part, in which you can high levelly you can see the calculation engine and planning engine. So apart from these engines, you will have some engine called OLAP engine. You have a join engine. You have a calculation engine. So you have a row storage engine and column storage engine. And you have something called graph engine. So each engine has its own task. Each engine has its own task. For example, if you are performing some complex calculations, so which engine will be called is calculation engine. If you are doing some kind of planning related activities with respect to the BW system, so there is an engine called planning engine. So what kind of planning? So actually you have a planning system, separate system. When you are integrating that with the HANA database, the planning planning related activities will be performed by this engine. So in HANA, it is designed in such a way that each engine has its own task. If you say OLAP engine, we have something called analytic views in HANA. We will discuss what is analytic views in the next classes when we start the modeling. So whenever we are hitting analytic view, there is an engine called OLAP engine which will be actually okay. So this OLAP engine will be, triggered. So when we have another kind of views called attribute views. So those attribute views will be triggered using this join engine. So the join engine will be triggered whenever you are accessing the join attribute view. So similarly, when you are actually accessing the analytic view, there is an engine called OLAP engine. We have some other kind of engines called, some other types of views are called calculation view. So this calculation views are useful. This calculation view is useful in different ways. The calculation views, whenever you are accessing the calculation views, there is an engine called calculation engine, which actually triggered whenever you are accessing the calculation view. Similarly, when you are performing complex calculations, there is an engine called a calculation engine within that. Similarly, we have something called graph engine. It has its own task to perform. So it means what I wanted to say here is within HANA server, within HANA database, they designed a different engines to perform a different task. To perform a different task. So once you do all these performance, data processing performance, but the question here is where you will build the models. The models will be built in the HANA Studio. HANA Studio is a front-end tool. HANA Studio is a front-end tool which is used. HANA Studio is a front-end tool which is used by the developers like you and like me and like other developers. So remember in the demo class I said HANA database can be installed only on Linux environment, Linux operating system. So as a developer, you need to work in the Linux environment? No, not required. So there is a front-end tool, IDE, you can call it as IDE. It is an Eclipse-based platform where the developers will be connecting the HANA database in the HANA Studio. We call it as SAP HANA Modeling Studio. This is a front-end tool. This is a front-end tool. Actually, you would be connecting to the HANA instance. You would be connecting to the HANA instance using this HANA Modeling Studio. Yeah. So HANA database would be installed in the Linux environment. HANA database would be installed in the Linux environment. But the developers will be installing this HANA Studio, Modeling Studio in the Windows environment, and they will be connecting from the Windows environment to the Windows environment to the Linux environment wherever it is connected. It looks like this. For example, this is my HANA database which is installed in Linux environment, SUSE Linux, especially this is SUSE Linux Enterprise Server. Now, as a developer, you are working in the Windows environment. This is your Windows system. Let it be. This is your Windows system, Windows environment. Microsoft Windows, be it Windows 8 or Windows 7 or whatever. Now you would be installing a piece of software within this Windows environment that is called HANA Studio. This HANA Studio would be installed in the Windows environment. Then you would be connecting. HANA Studio. Through HANA Studio, you would be connecting to the HANA database which is installed in the SUSE Linux environment. So it means through Windows environment, the developer will work in the HANA database using HANA Studio, which is a front-end tool, which is an Eclipse-based platform, nothing but Java-related platform, which can be installed in any platform. How does it looks like? Let's see. Let me connect to the remote server. So this is my remote server. So here if you observe, a tool is installed called SAP HANA Studio. So with this, within this studio, there is nothing is there. It is just a tool. So through this tool, I could connect to the HANA database. I could connect to the HANA database, which is installed in the Linux environment. See here, there is already a system has been already added. We will see how to add the system symbol. So if you see, there is a green symbol over here. It means I successfully connected to the HANA database. So no need to worry about this. I will explain this things all the process later. So I just wanted to show you how the HANA Studio looks like. So that is our HANA Studio. Through HANA Studio, we would be working in the HANA database. We would be developing the models. We would be processing some data previews within the HANA Studio. Okay. So that is what your HANA Studio, which is also part of your HANA database. Okay. Now, as soon as you develop the models in the HANA database, the models or the objects like views. We have different kinds of views are there which we develop in the HANA database using the HANA Studio, the front-end tool, HANA Studio. So we would be developing a lot of objects depending on the business requirement. Those models would be consumed in the reporting layer. The reporting layer here is anything. It could be SAP BO reporting layer, it could be Tableau, it could be ClickView, or any other reporting third-party tools. So whichever supports SAP HANA, so any kind of reporting tool that you can use. The customers who are actually using SAP reporting tools, they would integrate SAP BO with SAP HANA. Those customers who are actually using non-SAP reporting tools like Tableau or ClickView, these customers will be connecting to the or integrating to SAP HANA to make a reports out of SAP HANA models. This is the high-level picture. The same picture can be shown in another way like this. If you see here, SAP Business Suite or other data sources or any other source system. Through these systems, I would be replicating the data to the SAP HANA database, which is an in-memory computing system, which is an in-memory computing database. As soon as the data is available, we would be developing the models on top of those data. These models would be consumed in the reporting layer. The reporting layer here is the business objects tools or any other query tools, be it SAP reporting tools or non-SAP reporting tools, anything. This is another representation. So here, if you observe, I have a SAP Business Suite. Business Suite here is, it could be ECC system or CRM system or SCM system. If you are familiar with these systems, that is nothing but SAP Business Suite. If you observe here, there is something called real-time copy. Real-time copy. Remember in the last demo class, we were discussing about real-time data access. Real-time data access. So through SLT, we would be accessing the real-time data which is generated in the form of a transactions in the source system. So we would be seeing how to use SLT to access the real-time data. So real-time data is nothing but the moment transaction created in your source system, immediately it would be available in your target system. Unlike other systems, unlike traditional systems, you need to push the data to the target system. In the traditional system, what we were used to do, we used to push the data to the target system manually using a batch loads. Now you don't need to do that. Using a real-time replication, as soon as a transaction created in the source system, let's say Walmart created some transaction for last 5 minutes, it's generated almost 20 million transactions. So just imagine 20 million transactions are generated for the last 15 minutes by Walmart. So all these 20 million transactions will be immediately replicated to the HANA database. That is called real-time replication. So in general, earlier before HANA was coming to the picture, what was the case was, so at the end of the business day or end of the business week, we move the data from the source system to the target system. So what was the drawback there? So you need to wait for the data. There is a delay in the data. There is a delay in the data. So now there is no more delay in the data. See, traditional system could be anything. Traditional system approach means I am talking before HANA was coming to the picture. The approach, the databases or the systems that we were using is called the traditional systems, legacy systems, you can say. So, in the traditional old systems, we don't have a facility called real-time replication. We don't have a facility called real-time replication where using this real-time replication approach, the data would be replicating to the HANA database. But in the earlier systems, in place of HANA, there could be any analytical system, be it BW or be it any other Oracle related database or DB2 database, anything. But what was the case? You need to push the data manually. At the end of the day, it could be, or it could be at the end of the week, or it could be end of the month also, depending on the business requirement. What was the problem there? You need to wait for the data. There is no data readily available for you to do the analysis. If I want to see what is my sales status for last one day or last 5 hours, it was not possible earlier because the data itself is not available in my analytical system. But now the data is readily available. The data is available on the fly as soon as the transactions created in your source system. So how it is possible? Using the real-time copy, nothing but real-time replication. So when I say real-time replication, there is something called SLT. There is something called SLT. So what do you mean by SLT? We will discuss that data provisioning part. That is nothing but SAP Landscape Transformation Replication Server. It's a kind of ETL process that we would use to replicate the data at real time. Okay, some business may say that I don't want real-time replication, but I want to use some other tool. Is there any other tool available? Yes, that is called DS, Data Services. So that is what I was showing here in the previous slides. These are all your source. Source could be anything, that's what I'm saying. To replicate the data to the HANA database, your source could be anything. Even your source could be a flat file also. Even your source could be a flat file also. So source could be your ECC business suite or SCM system or CRM system or BW system or flat files or any other non-SAP system also. It could be Oracle apps, it could be any other DB2 separate system or anything. Okay. So once the data is readily available in your HANA database, we would do real-time analytics. Real-time analytics. So what do you mean by real-time analytics is nothing but you first of all you need to create a models, objects, information models within HANA on top of the tables. That is nothing but your modeling part. So I will discuss that. Yeah. So as I was discussing, there are different kinds of engines would be available within SAP HANA database. What are the different kinds of engines? So maybe you may expect a question in the certification. So when you are actually using a calculation view, which engine would be called? When you are using a analytic view, which engine would be called? These kind of questions you would expect in the certification. So this engine is responsible for the calculation view. There is something called some object called calculation view in HANA. Whenever you are previewing the data from the calculation view, which engine will be called? A calculation engine. Similarly, there is another engine called OLAP engine. This engine will be called whenever you are using analytic view. There is something called analytic view. This view, whenever we are previewing the data or triggering this view in the background, which engine will be called? That is OLAP engine. A join engine, it is for attribute view. We have something called attribute view. You don't need to worry what are these views, because we didn't start anything about the modeling. During the modeling you can understand what are these views and all. Okay, so the row storage engine. So remember in the demo class I said SAP HANA is capable of creating tables in the form of row based structure as well as column based structure, right? So whenever you are creating a row based tables and you are accessing those tables, which engine would be called? The row based engine. Row based engine. So here there is similarly we have something called column store engine. So what is the purpose of this column store engine is, when you are creating a column or table, when you are performing actions on column or tables, which engine will be taking care of that? That is column storage engine. Column store engine. So OLAP is nothing but online analytical processing. The word we generally use OLTP, OLAP. OLTP stands for Online Transactional Processing System. OLAP stands for Online Analytical Processing. Okay. So we have another component called SQL Optimizer, which is part of the index server. So I'll discuss this in the index server part. So if you observe all these engines, where these engines are inbuilt, if there is any separate container to hold all these engines within SAP HANA architecture? Yes. We have a different kinds of architectural part that we will see. This is what I was telling. Calculation engine is responsible for calculation views. OLAP engine is responsible for analytic views, and the join engine is responsible for attribute views. You just remember the words calculation views, analytic views, and attribute views. You just remember these words. So we would be discussing these in detail when we discuss that modeling part. Okay. Yeah. So where all these engines are available? Where all these engines are available? So there is any container to hold all these engines? Yes. On a whole, HANA database is mainly divided into four main servers. Four main servers. What are those main servers here is a name server, index server, statistics server, and preprocessor server. There are totally four main servers are available within HANA database: the name server, index server, statistics server, and preprocessor. You remember just now I was discussing about many types of engines: calculation engine, OLAP engine, join engine, row storage engine, column storage engine, planning engine. So all these engines, where all these engines are available? So all these engines are available in a server called index server. The index server is a heart of HANA database. Index server is heart of HANA database. So all the engines, all the data processing will happen inside your index server. You may expect a question in a certification: which of the following is the HANA database server. So they may give all the four options. Or you can expect a question like, which of the following are the functionalities or functions of index server? So the index server holds all the engines, index server holds the data, index server processes the data, index server takes care of the backup of the data. So everything would be done in the index server. There are other servers like name server. Let's talk about a name server. In a multi-node environment, this is a node 1, this is node 2, and this is node, let's say node 3. Node 2, node 1, node 3. Multi-node environment. So it means you have 3 nodes are available in the setup, hardware setup. So in each node, you have an index server, right? Index server is here, here, and here. Now, when the data is actually need to process, who will assign the task to the index server? Let's say there are 3 index servers are there. Who will assign the task to the which index server? That is nothing but the name server. The name server actually is like an administrator. He's like an administrator. Whenever the data need to be processed, he knows which index server is actually idle, so that give the task to that index server. So the name server is just like administrator. But who actually process the data? The index server. So which contains all the engines, which itself having its own architecture. The index server itself having its own architecture that I will be discussing. Next is statistics server. The statistics server is responsible for maintaining the statistics of the system, like performance of the system, how my system is performing, how healthier my system is, all the metrics or statistics related to the system will be captured by this statistics server. Like if the system memory is almost in the threshold limit, how would you know that it's almost reached the threshold limit? So there is a statistics server which actually takes care of all these measures. At the same time, if the system performance is very poor or very good or average, so how you will know that? So based on the statistics server. So this statistics server will be taking care of the performance of the system. Similarly, we have another processor or server called preprocessor server. Preprocessor server. So in HANA we do a text analysis, call it as text analysis. So whenever we are dealing with text related analysis, searching or something related to the text processing, so there is an engine called preprocessor, sorry, there is a server called preprocessor server which would be taking care of it. Text analysis is related to the preprocessor. So which server is main important here is index server. Remember, the index server is the heart of HANA database. The name server will be assigning the task, the data processing task to the respective index server whichever is idle. That is what the task of your name server. The statistics server will takes care of the health of the system, like the statistics of the system, the performance of the system. So we have another server called preprocessor which takes care of the text analysis. So when someone asks you where actual engines are available, where actual data is resides, where actual data process happens is inside your index server. So index server is the heart of HANA database. Index server is heart of HANA database. So the index server itself has its own architecture. Index server itself having its own architecture. Let's see how does it looks like. This is the architecture of index server. So far we have seen the high level architecture of HANA. High level architecture of HANA. So in which you have multiple servers are there. Now if you go into the deeper, if you go little deeper into the HANA architecture, the index server itself having its own architecture. This is how the index server architecture looks like. So whenever the end user access the data from the front end query, let's say I'm an end user, let's say I'm an end user, I'm sitting here and I'm accessing the data through a front end tool called Vivo reporting tool. Let's say I have a Vivo reporting tool. So through Vivo reporting tool, I am accessing this reporting tool. Just hold on, please. Yeah. So here the end user want to access the data from the reporting layer. But what is the source for this report? HANA is the source. So whenever the user is accessing the data from the front-end tool, how the front-end tool going to access the data from the HANA? So who is responsible to give the data? The index server. The inside HANA you have something called index server, which actually taking care of the data processing. The moment the user files the query, what happens is first the connection will be established. The connection would be established between your Vivo environment and HANA environment. The connection would be established between your Vivo environment and the HANA environment. So after that, the session management will be taking care of the sessions. So remember, when you log into Facebook or when you log into some other tools or some other social media network, the sessions would be maintained. Even when you log into the Gmail or your office mail, the session would be maintained up to 2 hours, 3 hours. After 3 hours, automatically the session will be closed. Right? Who will be taking care of that? There is a component called session manager. This session manager would be taking care of your session manager. So to establish the connection, who will be taking care? There is a component inside your index server called connection manager. The connection manager will be taking care of creating a connection between your front-end tool and the HANA, and then session manager will taking care of creating the session between creating a session for the user. It could be 5 minute session, it could be 10 minute session. Okay, so before creating the session, after the connection, there is a component called authorization manager who will be taking care of whether you are the authorized user or not. So if you are an authorized user, then only the system will allow you to access the data. If you are not the authorized user, the system will not allow you to access the data. So that is important point here. The system will not allow you to access the data if you are not authorized user. But how it will check? Who will check that whether you are authorized user or not? There is a component called authorization manager which will be taking care of whether the user is authenticated user or not. Because I am explaining each and every component because you would expect a question in the certification. Next, let's say your authentication is successful. The user which logged in is the authenticated user. Next, there is something called transactional manager. Nothing but when you are accessing the data, what actually you are trying to do here internally, you are actually creating a transaction to access the data from the database. You are nothing but you are creating a transaction. Even though you are logging to the Facebook or Gmail, nothing but you are actually filing a transaction to the Facebook server or to the Gmail server to access the data from the server. Similarly, when you are accessing the data from the Vivo reporting tools, it is actually creating a transaction in HANA to access the data. So who will be taking care of the transactions? There is something called transactional manager. So the transactional manager would be taking care of the transactions within the HANA database. For example, you are trying to delete something, someone trying to access something, or vice versa. You are trying to access something and someone actually trying to delete something. So will it be acceptable? No. There should be a log. So this log will be actually maintained. There is a component called a transactional manager. So all the transactional related activities will be maintained by the transactional manager. Okay. Now, as soon as the transaction starts, there is something called execution and process engine control block. You can say execution and process control block. This entirely we can call it as execution and process control block. So you remember just now I said the data processing happens inside your index server. This is the architecture of your index server. Within the index server, I have a components called SQL engines, SQL script, calculation engine, optimizer, plan generator, execution engine. Like these different engines are there. So all these engines and the components are responsible for processing of your data. So which all part of your index server. That's the reason why I say index server is heart of HANA database. Even when you go interview, they may ask you questions like explain about index server. So what are the process happens inside your index server? So these kind of questions you may expect. So the execution and control block is again the part of the index server where actual data processing happens. Okay. There is another component called metadata manager which deals with the metadata information. Like metadata is nothing but your table related information, structure related information, but not the original data. Okay. Now, these are all different engines, text engine, column or storage engine, which entirely this is process and control block. This entirely you can call it as execution and process control block, where the data processing happens here. Okay. Now let me discuss again from the first is here the user fires a query from the front-end reporting tool. The first connection would be established. Then if you are authenticated user, the session would be established. The connection and session manager will be taking care of it, and the authentication would be taken care of by the authentication manager. The transactions when you are accessing the data, that is nothing but select query or any transactions you are filing on the database. There is a component called transactional manager which will be taking care of it. Now, as soon as when you are processing the data, there is a block called execution control block in the middle. All these components are part of execution control block, which contains different kinds of engines, which contains different kinds of components like SQL and SQL script, MDX. MDX is mainly multi-dimensional language. Whenever you are accessing the data to the Excel related tools, multi-dimensional tools, models, in that case MDX would be helpful. So which is always part of your indexer. Okay. Now if you observe in the bottom, there is something called persistence layer. There is something called persistence layer. See, this is actually part of the basis topic. Let me briefly explain you what is persistence layer. Remember, I keep telling one point that HANA is an in-memory database. HANA is an in-memory database. What do you mean by in-memory database? The data processing happens in the RAM. The data resides in the RAM. What if power goes, some disaster happens, or system got shut down? Is entire data would be erased? Yes, obviously the data would be erased. If it is a production system, what would happen to my data? So, if it is a banking related production system, some transactions are happening, you are depositing something, someone is withdrawing something, at that particular point of time, if power goes, entire data would be erased. So what would happen to my transactions? Will my transaction will be rolled back? I withdraw 10 lakhs. So all the 10 lakhs will be affected in my account or not? I deposited 10 lakhs. So when I already paid the 10 lakhs, if the transaction is not affected, who will be losing? The customer. So the banking, finance related industries are very, very important. The data is very important for them. So for those kind of industries, this kind of product is helpful or not, because you're keeping the data in the RAM. RAM is temporary memory. It's not permanent. As soon as the power is there, then only data resides. Yeah. So for that reason, we have something called persistence layer. For the worst case scenarios, HANA is not only the RAM. Remember, HANA means not only a RAM, it has the permanent storage location as well. But actual data resides in the RAM, but it takes backup of the data if any changes happens into the permanent storage location. That is called persistent storage. Persistent storage or persistent layer. So it means what I'm saying is HANA will be taking care of backup of data at each millisecond into the permanent storage location. When the power goes, when a disaster happens, what happens is the system will get restart so that it takes the data from the permanent storage location. There is no effect to the data. There is no effect to the transactions. So the transactional information and the data would be taken care of by this persistence layer. So the data would be stored in the permanent storage location. But in the real time, when the production system is on, the actual data processing where it happens in the main memory. When the disaster happens, from where you will pick the data again from the source? No. The HANA itself having the permanent storage location like Oracle database, it has its own disk-based memory. HANA also having the disk-based memory, which is mainly used for the backup purpose. So when you restart the system, the data will be taken back up from the main memories, from the disk-based memory. This is how it works. So what we discussed so far is this is different kinds of servers that HANA has: name server, index server, statistic server, and preprocessor. And then within that, index server is the main heart of HANA database. This is the architecture of your index server. So in this picture, a little more explanation has been shown here. If you observe, this is my source system. With this source system, I am doing a replication server. It means it is SIT. This is another source. Through DS, I am replicating the data. This is a batch load. What is the difference between SLT and DS? We will come to that point later. So here I am loading the data from one source. This is another source. And if you observe, this is a HANA Studio. You are connecting to HANA database using a driver. Different kinds of drivers are there. This is my reporting tool. You would be connecting to the HANA database. This is another way I am just representing. It is not a separate architecture, just another way around I depicted here. Yeah. If you observe, there is a new engine has been added here. We call it as XS engine, which has been added from SP5 onwards. What is the current version service pack of HANA? Is SP9. From SP5 onwards, there is a new engine added called Extended Services Applications Engine. Extended Services, X stands for Extended Services Engine. Extended Services Engine. So what is the purpose of this engine? Why it is used? So earlier, before this engine was introduced, if you have a HANA box here, you need to maintain a separate box for web services. separate server for web services. So whenever you need to integrate with a HANA, you need to maintain two different servers. One is a HANA, another one is a separate web server. Now, with the help of Access Engine introduction from SP5 onwards, this web server also part of your HANA. This web server also part of your HANA. It means whenever you are developing applications, that is web-based applications on top of HANA, you don't need to maintain a separate web server, but it is a part of HANA now. That is called Access Engine. Especially the applications which are related to the web-related applications when you are developing. So in that case, we have an engine called Access Engine. You will expect a question from this Access Engine in the certification. Remember, since it is a new component. So this is a multi-node environment, distributed system. The distributed system, how does it looks like is, this is one node, this is one database system, this is another database system, this is another database system. You can see all the different kinds of engines here. The client application will be running on top of it. It is a distributed system. You have a single system or distributed system. In the distributed environment, you have multiple databases will be maintained across. For example, I have a business which is scattered across multiple countries. In that case, I would be going for the distributed system. So one server is located in Singapore, one server is located in India, another one in UK, another one in US. So if you are integrating all four together, that is distributed system. It is possible with the HANA as well. It is normal concept. So these are some of the features with respect to HANA. You can deal with OLTP as well as OLAP system, structured and unstructured data. It is not pure unstructured data like CSV files related data. You can load the data at real time. You can load the data at a batch load. You can do planning activities, predictive and statistical analysis also you can do. So these are the different features of HANA. So this is about the architecture part. So let me quickly recap this. So this is my high-level architecture of HANA, in which you can see three layers, in fact four layers. The layer 1 is a source system layer, layer 2 is a data provisioning layer, layer 3 is a HANA database layer, and layer 4 is a reporting layer. So the database resides in one operating system. We communicate to the HANA database using a tool called HANA Studio, which is installed in the Windows environment. Different kinds of engines: calculation engine, molap engine, join engine, so row store engine, column store engine. We have different kinds of engines are there. Different kind of server on high level, four different servers, in which index server is the main server. So we have separate architecture for index server. This is the architecture. And there is a separate engine has been added from SP5 onwards called Access Engine, called Extended Services Application Engine, which is mainly used for web related applications when you are developing the applications on top of HANA. This is the distributed system. How does it look like? Yeah. So any queries from anyone with respect to the architecture?
Hi, Krishna. This is Surendra here.
Yes, Surendra.
How we differentiate with this architecture with any of the ECC architecture or kind of a BW architecture? It's similar like a BW architecture, but it's something where a developer role is involved.
No, at the beginning of the class itself, I told with developer had nothing to do with the architecture. This is just for the understanding purpose. Like before you learning any technology, you should know what is the architecture part. That is one thing. The second thing, when you say it is similar to the other architectures, no, it is a little different because here each task would be divided by the different engines, each engine. So if you see there are so many engines, I have listed only few engines here. There's so many engines will be there, so that the task is dedicatedly assigned to a particular engine. So that the performance as well as the processing performance would be high compared to any other architectures. So that is what the main difference between any other architectures. A developer role is nothing with respect to the architecture. So you may be thinking, you may be, correlating this with a BW. That's actually the problem. So that is completely a different. BW is an application with a database, but HANA is mainly a database. So within which we have a different servers. So in the last class I discussed application and appliance difference. So if you're looking for the architecture point of view, like how the data models looks like in the BW point of view, you would be dealing with the LSA architecture, LSA plus plus architecture. This is not that architecture I'm dealing with. This is architecture of the system. So if you are looking for that kind of architecture, we would discuss in the modeling part. Is that clear?
Okay, okay, fine. Yes, okay, okay, Krishna. Yeah.
So any queries from anyone? I just unmuted everyone. If anyone have a queries.
Is there, this is again Surendra,
Yeah.
is there any possibility that existing systems can be upgraded to HANA? Either any of the system, either
Yeah.
ECC or
Yes, yes.
BW, any system?
Yeah, in the last class I showed you, right? One second. ECC would be upgraded to HANA, BW would be upgraded to HANA. This is what I was showing. This is the standalone where you are nothing to do, sidecar. Separately you are installing HANA as a sidecar. So this is one kind of approach. This is where your BW system would be upgraded to the BW on HANA. So these kind of projects are called BW on HANA projects. So first you need to migrate a BW into a 7.3 version and then plug in this HANA database to the BW. This is called BW on HANA. So there is another kind of project called Business Suite on HANA where you would be migrating your ECC system to the ECC powered by HANA. It means you need to upgrade your ECC to some version that is 6.0 and then plug in your database to HANA. So this is again HANA Live. This is also migration.
So
Only
that means
without, yeah, go ahead.
that means because I'm a ABAP more into the ABAP background.
Mhm.
So if ECC system, suppose let's say we have written all more than 700 objects. We have built 700 objects.
Mhm.
So in that case, when you migrate or when you upgrade this to HANA,
Mhm.
is there any conflicts that will occur? What are the major conflicts that may come occur in HANA? Is there any, or it's a smooth and we can do HANA migration?
See, the migration part is a separate part. So
Uh-huh.
yeah, there are some steps to be considered when you are migrating from ECC Oracle to ECC HANA because there are so many ABAP routines that you maintain, so many objects that you created with the ABAP. So when you are migrating to the HANA, the structure, the what do you call, the syntax also will be changed. So that is called ABAP on HANA. There is a course called ABAP on HANA. So that actually deals with migration and how to change the ABAP code, ABAP objects when you are using underlying databases HANA. You're right, absolutely right. Yes, there are some challenges out there.
Okay, okay. Thanks for the clarification.
Yeah, Satish, actually when you are keeping the data in the main memory, when you hit the query, when you fire a query, the data directly hits the RAM and takes the data. Okay? It means there is no transfer. There is no transfer of the data. Let me explain a little more. I showed you this picture in the last class. Yeah, here it is. If you see this picture, that is the difference between the traditional system and in-memory system. If you see, this is my hard disk. The database layer here it is hard disk. Here the database layer is a RAM. Now when you fire a query from the reporting layer, first the database layer will transfer the data to the application layer. The amount of data it transfers is huge. The finally whatever the results that you processed will be passed to the presentation layer. So what is the drawback here? You are unnecessarily transferring the data from database layer to the application layer. The transfer of data will be moved from database layer to the application layer, so which is actually the resource effective, which will consume the resources, extra resources. In case of in-memory computing, the data will be processed directly in the RAM because your layer itself is a RAM. You're not picking the data from the hard disk. In this case, the RAM directly you are processing the data, only the results will be processed. There is no transfer of data from one layer to the other layer. You are pushing down the logic, your application logic to the database layer. Less burden on the application layer in the in-memory computing. More burden on the application layer in the traditional system. Transfer of data is high in the traditional system. Transfer, no transfer of data in the in-memory computing system. Is that clear? So any queries from anyone? See, for every system there are alternatively disadvantages also there. Like HANA, first of all, it's a cost effective. Not everyone can afford that. And the second disadvantage is it is not a standardized product when compared to BW or any other products. It is released in 2011, late 2010. It's just 4 years old product. Still, they are actually standardizing the product. There are some bugs are there. So, but the purchase wise, the improvement wise, it's very drastic. All the functionalities you may not directly apply in HANA. That's few functionalities are there that I cannot directly explain it now. When you actually practice, during that time I can explain you by comparing it with other systems. Any question from Raj and Nagraj?
No, Krishna, not at this stage.
Okay. Okay, then if no queries further, We will meet tomorrow same time. Okay. Good day. Have a good day.